Hello, I'm Steve Garrison, and I'm here today to talk about the Open Data Center Framework. Let's take a look. With open networking, our idea is to parallel the server world. With servers, we have white boxes, abstraction technology, many operating systems, and lastly, a movement towards open source orchestration software. For PK8, we're pioneering by also leveraging white box technology. We've also built in an abstraction layer and exposed Linux in our operating system, as well as supporting Open Virtual Switch from Nicira. Open Virtual Switch today allows us to have an OpenFlow agent to talk with leading controllers such as Ryu, Floodlight, and Knox, and also build Layer 2 and Layer 3 networks. Today, we have chassis-based switches in the core and top-of-rack devices on the edge. This is a great way for PK8 to start with you. We have a full suite of Layer 2 and Layer 3 features, including BGP. On the right, we've seen a movement towards mesh technology with hyperscale data centers. In particular, companies like Microsoft and Amazon have published white papers on this topic many years ago. This is also a great way to leverage PK8 for this idea of rip and replace. The idea that the software abstraction technology we mentioned before gives you the ability to make changes in your hardware without disrupting your management and operations framework. We also think white box technology helps you drive down CapEx. Now, looking on the operational side, by moving to mesh, you're moving from intelligence centered in the core to distributed intelligence throughout all the devices. We think this lays the foundation for external programmability from one of the OpenFlow based controllers I mentioned before. Let's now take a look at some of the building blocks that are featured in our operating system today. And these are great use cases to understand how we have the foundation for a programmable and agile data center network. The first example is traffic engineering. In fact, Google is using this in production to manage their WAN costs and make sure that application flows get the best or fast path. Within OpenFlow 1.2, you do have statistics that help you analyze utilization. And in conjunction with understanding which path is best based on those statistics, you can use your Ryu controller, for example, to redefine the path on the fly. This is a great use case to see how simple it really is to use OpenFlow. Tunneling's been around for years as an idea, and certainly more recently highlighted as an overlay technology by Nicira. The goal here is to basically connect two domains without disrupting the overall network fabric itself. That's why a tunnel is such a great idea to connect two domains. Obviously, moving virtual machines between those domains is the use case most people are familiar with, but we'll cover some other use cases on the next slide. Last but not least, there's been a lot of excitement lately around network taps. With OpenFlow, you can build these with any switch port, and OpenFlow 1.2 gives you a lot of functionality to leverage. We see a big advantage here in CapEx by not having to have a fixed overlay network to provide connectivity to your taps. You can now build it dynamically. You can do spot checks. You really get to see the flexibility and granular control that OpenFlow technology gives you. At the end of the day, all three of these building blocks help you build a faster, better utilized network fabric, ensuring applications are delivered at the performance levels you'd expect. Let's take a look at another way to present this information and tie some of these things together so you can see how we believe these three building blocks give you the foundation for programmable and agile network. Here, we're looking at Hadoop, a very latency-sensitive application. Applying traffic engineering in this case, we're ensuring that the fast path is chosen, increasing Hadoop cluster performance. Our next example using tunneling shows VM orchestration. Another use case might be connecting two Microsoft Exchange servers across disparate data centers or even over the WAN. And lastly, the idea of looking at taps dynamically and selecting the switch ports that you'd pull that information from. Here we want to monitor MySQL performance. In many cloud environments, MySQL is used to gather all the MTU data, and so knowing the performance of these servers is critical to guarantee customer SLAs. Now I want to summarize the Open Data Center framework. First, we have a set of production-ready OpenFlow 1.2 based building blocks which are available in PK8's operating system today. Second, these lay the foundation for the programmable and agile data center we all strive. And our customers are telling us to forge ahead and continue to develop technology to get them there. And lastly, what's next? Well, we'll be detailing how to manage and provision these building blocks over time. Well, that's it for now. Stay tuned for updates on open networking at pk8.com.